Good afternoon. Good afternoon. Hello. Hello, good afternoon.
Good afternoon.
One of Uganda. Are you online? Yep. So we had introduced momentum, as you recall, and I had given you some numbers that could help you show or prove some concepts in momentum. So I wanted to know if there are some of the numbers that I gave you or that we shared that came out as challenges that you want me to look at. I remember some numbers I gave you that were from from what? From Kauma's book. Huh? So I wish we could look at one number or two, or we can introduce something else. So if you look at some of these examples I gave, those of us who managed to get these notes, look at these notes. There are these numbers I told you try out, these trial questions. The people try some of them. I'm going to do number 3 and number 4. Can we take screenshots? So take a screenshot for this number. Take a screenshot for that number. Then the rest will be discussed by you. You try them out. So let me also take a screenshot for those numbers so that I can be in position to. Okay. So I've shared the numbers on WhatsApp. So if I may go back to our right page. The first question says, let me start with number 4. A body explodes to produce 2 fragments. It means this body was initially this huge, then it has exploded into 2 different what? Fragments. Of mass is small m, capital M. So we can have the velocity of the fragments are u and v respectively. Show that the ratio of the kinetic energy of the fragments is E1 to E2 is equal to capital M, small m. Now, if the body has exploded, on exploding, they separate. One may go in that direction, the other may go in the opposite direction. But now, I said, so momentum conservation, initially they were at rest before the fragment exploded. So the momentum before was 0 is equal to the momentum after. And with this, you will see that small mu is going to be equal to capital M V. Now their kinetic energies can be equal to, I have E1 for the first one, which is a half mu squared. Then for the second one, it's going to be a half capital M V squared. And if I may divide, you will see that the ratio of U out of V is capital M out of small m. So when you divide E1 over E2, you realize I have small m U squared divided by I have capital M V squared. You lose the half. So E1 out of E2, you realize small m out of capital M into brackets U squared out of V squared. With this, I'll have E1 out of E2 is equal to small m out of capital M into U out of V. With this, E1 out of E2 will confirm small m out of capital M into capital M out of small m but squared. So finally, you have E1 over E2 is equal to small m to capital M squared out of capital M of small m squared. You lose one capital M, lose one small m. So finally, the ratio of the energies E1 to E2 is equal to capital M out of small m. Hence proof. Okay, so that's the solution for that number 4. So having realized number 4, unless if someone has a question, no question, you can go for number 3.
Teacher, how did you out of it turn into capital M out of small m?
Those who want a screenshot, you can tell me and I go back. Amina Salim, can you read for me that number 3? Read the question.
A body of mass m1 traveling with a speed of u.
Read the question 3.
A body of mass m1 traveling with a speed of u1 makes a head-on collision with a stationary particle b of mass m2. If the collision is elastic and the speeds a and b after collision is elastic, and the speeds of a and b after collision are v1 and v2 respectively, show that for x equals to m1 over m2, then m1 over, teacher, it's not physical.
The volume is very low, I don't know why. Okay, according to how she has read the question, hope you've got to listen to what she has read. And then I expect some of you to have been in position to also see what has been read by her. Now, this question says, a body of mass M1, okay, this is assumed to be M1, traveling with a velocity U1, makes a head-on collision with a stationary body B. Stationary body B of mass M2. Head-on collision means they are facing each other. But this one was initially 0. If a collision is elastic, when the collision is elastic, they separate. When they separate, and speeds of A and B after collision are V1 and V2 respectively. Show that if X is equal to M1 over M2, then U1 over V1 is equal to X plus 1 out of X minus 1. Then also X is equal to V1 plus U1 over U1 minus V1. Then thirdly, V2 out of V1 is equal to X out of X1, X minus 1. Now, to start with, you look at momentum conservation. Momentum conservation. For momentum conservation, we have momentum before for M1, U1 plus 0 momentum for M2 is equal to, after collision, we have M1, V1 plus M2, V2. From this, you realize that M1, U1 is equal to M1, V1 plus M2, V2. Now, after seeing that, we can be in position to have the following. Okay, so having seen that momentum, you can divide everything by M1. When you divide everything by M1, you realize M1, okay, M2 out of M2 out of M2. You divide according to what the question predicts. So we shall have M1 out of M2 of U1 is equal to M1 out of M2 of V1 plus V2, which gives us XU1 is equal to XU V1 plus V2. Now the first proof does not have V2. So kinetic energy conservation will give us a half M1 U1 squared is equal to a half M1 V1 squared plus a half M2 V2 squared. When you lose the half, we shall attain M1 U1 squared is equal to M1 V1 squared plus M2 V2 squared. When I divide everything by M2, I will attain X into U1 squared minus V1 squared is equal to V2 squared. Yet up there, this is equation 2. This is equation 1. From equation 1, you can see X into U1 minus V1 is equal to V2. So when you substitute, you'll have X into U1 minus V1 squared is equal to X squared into U1 minus V1 squared. But this one, when you expand, this is the difference of 2 squares. So you get X into U1 minus V1 into U1 plus V1 is equal to X squared into U1 minus V1 squared. You can lose this with this one, remain with 1. Okay? So with that, you can get X into U1 plus V1 is equal to X squared into U1 minus V1. I'll lose this X with this one X. So I'll have U1 minus X U1 is going to be equal to X V1 plus V1. But both of these ones are going to be negatives. So finally, X into U1 into X minus 1 is going to be equal to V1 into X plus 1. The ratio is to find U1 over V1. So U1 divided by V1 will be confirming X plus 1 divided by X minus 1 in solution. So
I have a question.
In the second part.
Teacher.
Yes?
Teacher, I have a question.
Why is your volume low? I can't hear you well. Now I can get you. Yes, now you can ask your question. Hello? Your question? Amina, is that you? Mercy, you have a question? Mercy, what's your question? If you have no question, we go for the second one. The second one is to make X the subject from here. So Roman 2, I can start from U1 minus X U1 is equal to a negative X V1 minus V1. X U1 minus X V1 is equal to U1 plus V1. So X finally is going to be into U1 minus V1 is U1 plus V1. Finally, X will be U1 plus V1 divided by U1 minus V1. hashtag proof. Then the last question, as you can see, the last question doesn't have U1. So you make U1 the subject. From X U1 U1 is equal to over X. Then when you come here, you can substitute for U1. From energy, we have seen X into U1 squared minus V2 squared, U1 squared is equal to V2 squared. So this will give us X U1 squared is equal to V2 squared plus V1 squared X. So I can substitute for U1, I'll have X into brackets, X V1 plus V2 divided by X. This is squared, this is also squared, is equal to V2 squared plus V1 squared X. Because of this square, I can lose one X here. Then I cross multiply that X and I have X squared V1 squared plus 2X V1 V2 plus V2 squared is equal to V2 squared X plus V1 squared X squared. This one can be lost with this one. We shall have 2X V1 V2 plus V2 squared is equal to V2 squared X. I collect the V2 squared together into X minus 1 is equal to X V1 V2 divided by V2 V1 divided by V2 V1. So you can noise so V2 over V1 is the proof. Let me try to make that adjustment. I'll have that as I move to relocate. I hope I had answered your question by the time you had still the sound was still low, but you never rephrased your question, your concern. Okay. We shall not get interference with the network. So here we are. I hope the derivations have been. You want me to try out another one? I think those are enough. Those are now yours. Eh? One more. Okay, which one? Let's go back and you pick from that page. But you don't want to do numbers. Ha. You don't give me number 2. Yeah, but the rest are okay. I have to do number 1. I have to do number 1. Or I have to do number. Okay. Let me solve. I think you want me to solve which number? Which number should I try out? There's number 1. Number 2, you also try out and get to know that the world is not simple. So number 1 says a ball of mass 10 kilograms moving at a speed of 10 moving with a speed of 8 meters per second collides with another ball. This is ball A. B of mass 20. Initial at rest. After collision, A and B move in directions making 30 degrees and 45 degrees respectively with the initial direction. What does that mean? It means when they collide, A may B takes on this direction with the initial direction, which is 30 degrees. So this is A. Whereas B takes this direction with 45 degrees to the initial direction. Capture the speeds of A and B after collision. Now we don't know the speed with which A is moving. This can be moving with the V. Let this one be moving with the U. Now, you have to, because these are vectors, you have to resolve. One, we shall have a vertical component of U sine 45. We shall have a vertical component here of V sine 30. We shall have a horizontal component of V cos 30. We shall have U cos 45. Now, horizontally, get momentum conservation horizontally. That is why when we are defining the principle of conservation of momentum, we say algebraic sum of we say that the sum of momentum before and after collision is a constant in a given direction. Now, momentum will be, initially we had 8 times 10 plus 0 is going to give us, the horizontal component is going to be, A had what? 10 times V cos of 30 horizontally plus 20 times U cos of 45 horizontally, because this is the horizontal direction of B, this is the horizontal direction of A. Therefore, 80 will give us 10V root 3 over 2. So she was right to say, teacher, do some more. So this is 20U out of root 2. By root 2 once, by root 2, 5. So 80 root 2 is going to be equal to 10 root of 6V plus 20U. This is equation 1. That is coming from the horizontal direction. So if that is coming from the horizontal direction, we can now go ahead and also use the vertical direction and get momentum conservation. So momentum conservation will be vertically. Before these bodies were not moving vertically, so the momentum before is 0 vertically. But after A, the vertical component is acting upwards, which is going to be 10 times V sine of 30. Then the other one is acting in the opposite direction, so it will be a negative of what? Of 20 times U sine of 45. It is from here that we can see that 10 V times a half is equal to 20 U times 1 over root 2. From this knowledge, we can get 5V is equal to 20 U over root 2. So it means 20 U is actually 5 root 2 V, the second equation. So I substitute 1 in 2, I will have 80 root 2 is going to be equal to 10 root of 6 V plus 5 root of 2 V. Now I can make V the subject and say it's going to be 80 root 2 divided by 10 root of 6 plus 5 root of 2. Compute with a calc and get the answer. But I can lose root 2 by the way here, as this is 80 out of 10 root 3 plus 5. Then I simplify with a 5 to 16 out of 2 root 3 plus 1. What value do you get for V? Come on, computer, and give us the answer.
I've gotten 3.584.
You got?
3.584.
Are you sure? The question says, calculate the speeds of A and B after collision. We are wrong. The answer is 5.85 and 2.07. Where could I have gone wrong? Did I resolve correctly? V cos 30, yes, times 10. U cos 45, yes, times 20. Initially it was 8 times 10, which is 80. When I divided, it was root 3 over 2. Reduced it to 5. Yes, I see the problem. You see here, I cross multiplied this root 2 up, became a root 6. Here I had divided by 10, by 2 to 5. I still maintained the 10, which is wrong. Have you seen that? Guys, have you seen that error? This is a 5, eh? So if it is a 5, substitute here in the 5. So this is a 5. Let me substitute all. So we are going to have 80 root 2 is going to be equal to 5 root of 6v plus 20u, which is 5 root 2v. The v will become 80 root 2 divided by 5 root of 6 plus 5 root of 2. When you divide everything by root 2, you remain with a root 3 inside. The 5 can also go, remain with a 16. This will give me a 16 divided by root 3 plus 1. What do we get? The answer is 5.8685.
Five point eight
5.85 meters per second, making us steady. Then can you deduce for me u? U is equal to 5 root 2 times 5.85 divided by 20. What is the value of u?
two point zero six eight.
2.068 is approximately 2.07. Hence correct. Okay. Why don't you try out number 6 on this very note? But before you go there, the key item on these numbers is that you should know the following. Initially, there is a particle which is moving. Maybe this one was stationary, and after collision, they divert. One goes this way as particle 1. They divert from the original direction. One goes this way as particle 2. Sometimes they can tell you the angle between their new directions is 90. Or they tell you one is 30 from the original direction. So the most important thing is to know that if this angle is alpha and this one is beta, you have to resolve a component of the velocity vertically with this as v and this as u, with this as v sine alpha. Then for this one vertically downwards, you'll have u sine of beta. Then horizontally, this one goes this way with the v cos of alpha. Then this one goes that way with the velocity component of u cos of beta. Then those ones which are in the horizontal direction, they have momentum conservation with the initial motion, because initially they were moving horizontally. But these ones which are vertical, one is positive, one is negative. Initially, they do not have an initial what? An initial momentum. So that is the only trick behind these numbers. So with that note, can you try for me number 6? Right now. Yes. Answers, do they come out? We have around 8 minutes to finalize that number. Answers? You have 3 minutes. And you have the answers already there. You have 3 and theta is 27. So I expect you to work towards that. Hello? Time is up and no one has given an answer. So let me go through it. Okay. Has anyone got an answer? Who has come in late? Madina Tasneem. Hey, you're late today. Okay. We are looking at number 6. Number 6 is saying a smoker ball of mass 0.3 moving with a velocity of 5 hits a stationary ball Y. Ball X hits ball Y. Ball Y is stationary. Ball X.
Sorry, this is the wrong lesson. Bye.
Pardon? She has entered the wrong lesson. This one is of 0.3, this one is of 0.4. Y moves off. Y moves off with a velocity of 2 meters in the direction of 30 degrees with the initial direction. So Y has moved in 30 degrees. Then X Y moves, no, this was supposed to be Y. Y moves at theta, its initial direction. Find the velocity of X. No, this is Y. Okay, this is X, yes. Find the velocity of X, which we don't know. But this one moves with the 2 meters per second. This one moves with the V we don't know. So momentum before horizontally, you'll have 0.3 times 5 is equal to result of 2 to the horizontal, you get 2 cos 30. To the vertical, you shall get 2 sin 30. Whereas this one, we shall have V sin theta, then V cos theta. So horizontally, we shall have 0.4 times 2 cos of 30 plus 0.3 times the V cos of theta. You'll realize that this is 1.5 is equal to 0.4 root 3, because cos 30 is root 3 over 2. The 2 divides with the 2 plus 0.3 V cos of theta. So we can get V cosine of theta is equal to 1.5 minus 0.4 root of 3 divided by 0.3. Equation 1. Then vertically, we shall have 0.3 is moving down, a negative V sine of theta, plus 0.4 times 2 sine of 30 is equal to momentum, which is 0 vertically initially. We never had a velocity, a momentum in the vertical. So these 2 divides with a sine 30. So 0.3 V sine theta is equal to 0.4. V sine theta is 0.4 over 0.3. Therefore, V sine theta is equal to 4 out of 3. But remember, we also got V cos of theta as what we had. So let me divide by V cos of theta, which is 1.5 minus 0.4 root 3 over 0.3. I can lose the V with this one, then I get tan of theta is equal to 4 times 0.3 divided by 3 into 1.5 minus 4 root 3. Press the calculator and confirm theta. Someone with a calc, give us the answer. Master, can you give me the answer? Yeah? Cynthia, do you have an answer? You get the tan inverse of this one. Yeah?
I'm getting different answers.
What are you getting?
I'm getting 2.75.
2.7, eh?
2.75.
Someone else? Who is that? Cynthia?
Yes.
Or I missed a decimal somewhere. Another person?
.36 degrees.
20 point?
26.36 degrees.
26.36. This should be rounding off to 27, but it can't. Let me check again whether we have done everything right. So if you look at horizontal, we had 5 times 0.3, which is 1.5, correct? After collision, we had 0.4, the y moves with the 2 cos of theta horizontally, yes. 2 cos of theta is 2 root 3 over 2, the 2 divides 0.4 root 3, correct? 0.3 v cos theta, okay. Then I made v cos the subject. This one went the other side, yes. Then on this one, vertically upwards, we had y. Y is 0.4 times 2 sine of 30, which is correct. Then negative 0.3 sine of theta, which is also very correct. So v sine of theta is equal to 0.4 out of 0.3, which is 4/3, correct. Okay, let us assume it's right. Now let's go back here. That was theta, eh? Cos of 26.36, what do you get? Oh, use this one, eh? V sine of theta is 4/3. Now you put V sine 26.36 is equal to 4/3. Then divide this off and make V the subject. I've solved entirely what I wanted to solve, even including those deviations of angles. So next time I have to introduce a ballistic pendulum, which is used to estimate the velocity of a bullet. So when you use a ballistic pendulum, we shall see how we can go about it.
Three.
Exactly. So it means we were right. Yeah, we were right. I think that number, that answer, Mr. Kauma, miswrote it. Okay, I think those have solved enough. Please try out number 2. Yeah? Number 2 will be good for you to check out. And then the rest of those numbers, take a look at them. Okay, with that, we can call it off. Time is up. The next lesson is on.